All right, welcome to Module 5 of Programming Logic with Python. I am your professor, Professor Fiske, and I want to start off this Module 5 by speaking about iterative statements, because that's what the module is about. So what are iterative statements? Iterative statements are statements which we want to use to loop over or repeat certain programming lines of programming or programming statements that we have in our code. Now, what do I mean by that? Well, in case of this specific micro lecture, I want to speak very briefly about while loops. What is a while loop? A while loop is a loop which allows us to loop while a specific Boolean expression is true. So in this case, we're looking at W3 Schools. So I want to shout out W3 Schools. Thank you for the free content that you provide to us. If you have any questions about how to get to it, just send me a comment, and we can get to it very quickly. But in this case, what is a while loop and what does it do? Well, a while loop loops until the Boolean expression is no longer true. So what is this saying is while I is less than 6, I want you to run what's in here over and over again until I is greater than or equal to 6. And that's what this while loop is doing. In other languages, there's another loop that is the inverse to the while loop, and that loop is called a do while. Now, a while loop specifically determines if the Boolean expression is true before it decides to go in and do the programming statements in the loop itself or in the iterative statement itself. Whereas a do while loop, which you will not find in Python at the moment, but you'll find do while loops in Java, C#, C++, and the like, do while loops will execute the body of the loop before it tries to determine if the Boolean expression here is true. All right. With that being said, let's jump over to REPL and let's do some looping, shall we? Okay. Here we are, and we have a check input function that is basically used to check if the response is not numeric from the end user, and then it checks to see if the response is between 10 and 1. This is pre-code I wrote in another lecture. And so what I really want to do is I want to loop through this specific program. I want to loop through this script. And the way I would do that is I can do that in one of two ways. I can say, okay, well, I will say while, and I'm going to have to ask for the input. So while response not empty, and I'm unsure if that's the way to write not. I actually want to say like is not empty or something along those lines. As long as this response is not empty, the user didn't put the wrong value in there, or response is not exit, then I want you to go ahead and print that. Now, what's going to happen? And I just want to make sure that I'm not missing anything here. Response is not equals to, or, I guess I have to put the word or and not these two here. I can do that. Great. There, likes it. So in Python, the word or is a little different than the two pipes that you would find in other languages. We would have to say or. So if this first one is true, or if the second Boolean expression is true, then run this. And then just keep running it over and over again in the event that it is or isn't true. All right, fantastic. So in this case, what I actually want to do is this is going to return a value. We're going to print that, and then we're going to ask the user for another value. Response equals this. Because in this while loop, this is never going to be hit again. It's going to loop through the while, and then when the while is finished, it'll drop out of the while loop. So we have to ask this question twice. In a do while loop, we won't have to ask this question twice, because in the do while loop, it'll execute the body of the while of the loop first, and then it will determine whether or not response is equal to exit or not. So we're going to run this and hope that it works the way we want it to work, and then we'll debug it right after. All right, so please enter a number between 1 and 10. We're going to enter happy path because we just want this thing to work. There it is. Please enter the number is 5. Here we go. We're going to enter unhappy path now. Let's enter something that's not a number. That is working just fine. Pound sign is not a number. Please try again. Please enter number between 1 through 10. Okay, great. So let's stop this for a second. And I know I'm speaking fast because I want to keep this lecture short. Let's debug it to find out what's actually happening. So we're going to debug. I'm going to put a breakpoint at the first response. Normally you should put the breakpoint before you debug, before you start debugging. Hopefully it catches it. It looks like... There we go. Okay, great. So I'm going to So if you want to keep going in REPL and you're not using Visual Studio Code, the best thing to do is to go to the next breakpoint, or you can next step. Next step actually steps line by line. Going to the next breakpoint goes to find the next breakpoint, and if there is none, it'll just keep on going. So we're going to go ahead and step through it. So now it's asking me for a number. We're going to enter the number 5. Great. While response is not equal to empty string, or response is not equal to exit, then I want you to do these things. So here we go. Response is now being checked. So it took the input that I provided in the response variable here, and it stuck it into the input variable that I have as a parameter in the check input function. And then what it's going to do is it's going to turn around and do some response is not numeric. Why is it checking response? I don't like that. Stop. Let's do this instead. Input, because input's the parameter I want to check against. I don't want to check against the variable response. All right, there we go. Run. It worked just fine, but I didn't like the fact that response is not the parameter in the function, and because it's a globally scoped variable, it is available to the function, but I don't like the fact that I'm using that to do my determinations instead of using this parameter, which I'm passing the value in using the response variable here. So let's try this one again. We are going to stop. We're going to debug. All right, here we go. We're debugging. Perfect. We're back here again. We're going to step into this input. It's asking me to enter a value. I'm going to enter 5 again. This is our happy path. When it goes to the while loop, it's going to check to see if response is less than or equal to empty string, or is response less than or equal to exit. Great. Well, it jumps in. So now we're going to pass the value in response to the value here into input. All right. The input is numeric. Now, isNumeric is a function that goes out and checks to see if it can convert the input or whatever variable assigned value it receives to a number. It could convert 5 to a number, so it didn't. This was not true. Now it's going to check to see if it's between 10 and 5. This is saying if the input that's provided to this function, which is 5 right now, you can see that there on my screen, if the input is greater than 10, or if the input is less than 1, then it's out of bounds, which is true. But that's not the case here, because 5 is between 10 and 1. So now we're going to get the number is input, which is fine. That'll come back down into our while loop. And then it's going to print, the number is 5, and it's going to ask me again. Now, one of the things I did not check, and I'm going to check it right now with the debug, is if I enter empty string or exit, what happens? Well, if I enter exit here, then what's going to happen is the loop will stop. Or it should have stopped. It did not stop, which leads me to believe that this isn't working correctly. Now, this is something that happens a lot when you're writing loops. There's a interesting caveat that's occurring here that I'm not taking into consideration. So, what you want to do in this case is I'm going to now redesign this or refactor this based on industry best practice. What does that mean? Well, industry best practice for while loops in any specific setting is to create the while loop as an infinite loop from the get-go. So when we write while loops, we want to be very careful about the loops we create, because your loop can be infinite and never stop and crash your systems over time. So in order to prevent that from occurring, what we do is we create an infinite loop from the beginning. I'm going to say true here. True is a Boolean value that we've discussed in the previous chapter. If you don't remember what that is, go back a couple of modules and go look at the data types micro lecture to discuss about what a Boolean value is. Either way, a while loop is looking for the Boolean output of true or false. But we don't have to do a calculation to get this value. We can just say that this is always true. Now, what is this going to do? This is always going to present to us a conundrum. And that conundrum is This will always be true until we say it isn't true. So now I'm going to introduce a second thing that you need to know. We're going to talk about jump statements. What is a jump statement? Well, jump statements give us the ability to jump through our stack trace whenever we so desire. There are 3 jump statements you need to be aware of in programming, period. Okay, any programming languages, all programming languages contain either all 3 of these or some amount of these 3 jump statements. The first jump statement is break. The second jump statement is continue. And the third jump statement is go to. Now, go to, I have never, maybe once or twice in my 20-year career have I ever used go to. But break and continue I have used prolifically because, especially with loops, we use these specifically with loops. Break and go to do one of 2 things. So continue, all right, continue tells the loop that it does not need to run any more lines of code in the loop beneath it. It needs to forego this iteration and go back to the top of the loop. Break means don't run any more iterations, don't run anything else in this loop at all, drop out of the loop and run what's the next lines after that loop in the stack trace. All right? If that was confusing, please rewind it and listen to it again. So what I will tell you is what I want to do in this specific situation is I want to use jump statements to create, all right, I want to use jump statements to create exit conditions in my while loop. So instead of my exit condition being a part of my Boolean expression, here in this part of my while loop, what I actually want to do is I want to build my exit conditions directly into the body of my loop. Well, I have 2 exit conditions I would like to consider. The first exit condition is if response is not equal to, or if response is equal to this. If response is equal to, and I guess I typed this wrong in the Boolean expression, that's fine. If the response is equal to empty string, I want to notify the user that I will not be able to calculate what they're sending me, and therefore they need to give me a value of some kind. And the way to do this is I can check to say if response is equal to empty string, which is what that is, then I want to print, please, no value was provided, please try again, and then right after that I want to say continue, because maybe they hit enter by accident. Maybe they wanted to enter a value, but they weren't able to. So this exit condition is my first exit condition, and I have it at the top of my loop for a reason. Now I'm going to pause here for a second and ask a question. Why do you think I have my exit condition at the top of my loop instead of the bottom? Well, if you've paused the video to figure that out, I will tell you the answer now. The reason why I do these at the top of my loop is so that nothing below it runs. It makes my loop very efficient. I don't want anything to fire right after it that can cause an error. I also don't want to try to calculate something that I know is not necessary. So I don't want to fall into this at all. I have exit conditions up here as well using my return statement, which is technically a jump statement as well. So down here, I'm using continue as a jump statement to say if a response was entered of no value or empty string, then I want you to print a response to the user, and then I don't want you to run anything else in this loop, but I do want you to run the loop again, so continue. So let's debug this really fast, and let's see it in action. So we're going to be asked for a response or an input. I'm not going to enter an input, I'm just going to click enter. This is how you can enter an empty string into an input value, or into an input function. Empty string. So here we are. Response equal to empty string? Well, if I scroll over response, guess what it's going to say? It's going to say exactly that, empty string. 2 quotes is the same as 2 double quotes. So in this case, this is true. It'll fall in. It'll say, please, no value was provided. Please try again. And check out what happens next after the continue word, reserved word jump statement is hit. I go back to the top of the loop. Nothing below this fired at all, and that's exactly what I wanted. This is a valid exit condition, and I want to make sure that I catch this unhappy path. The second unhappy path is as follows. If response is equal to exit, all right, then print, thanks for using the program, goodbye, and then I want to break. Now, While continue allows the loop to continue to loop over time and not run the code beneath it, what break does is it breaks the loop entirely and it leaves the loop. Theoretically speaking, I wouldn't want this here. I would actually just want to break and at the end say, thanks for using the program, goodbye, no matter what. So in this case, we're going to debug again. Right now, we're going to debug here. We're going to do that. And then we can say, all right, please enter a number between 1 and 10. We're going to enter the word exit. It hit the exit, and guess what's inside of the string response? The word exit in the right casing, by the way, because that's very important. So now what's going to happen is it's going to break, and watch what happens next. It doesn't go back to the top of the loop, and it does leave the loop altogether. It prints, thank you for using the program, goodbye, and everything is nice and pretty. Now, there's one more thing I want to do to ensure this exit condition, this one right here, is valid. Remember what I just said. This string literal is specific to the E being capital letters and XIT being lowercase. But your user might not enter that information. They might enter all lowercase. They might enter all uppercase. They might do some weird stuff in here. So what you actually want to do is you want to use a string. I will advise that you use a string function called to lowercase. All right. And I believe that's the name of the function. Yep, to lower on the response variable to ensure that every time you get it, it will convert it to a lowercase. And now we only have to check one condition. Because if I did not do this, then I would need to write in here all the different ways that the word exit can be used and written. And I don't want to do that. I just want to check it one time. So what lower is doing is it's taking what's provided in the response variable, and it's saying, I'm going to convert all of those symbols, all those letters, to a lowercase. And now I can say, well, this is always going to be lowercase because that's how I'm receiving it, and therefore I'm going to get this. Now, there's a problem with lower because I believe that lower is also going to throw an error in the event that this is not a numeric value. So what I might need to do is check to see if it's not, if it isn't numeric first, and then do this. But let's check it out first. I don't want to speak too quickly. Maybe it'll work right without me having to do that. But we're going to run it. And in this case, I'm not going to enter. You see, I just turned the caps lock on. I want to test to lower. I want to test to lower to make sure it works right. So when it finally fires, it's taking its time. Oh, oops, I didn't mean to do it that way. I wanted to debug. My apologies. So we're debugging now. We are debugging now. REPL is one of my favorite IDEs, but there are situations where it does run a little slower than I would like it to. All right, here we go. Resolving dependencies. And here we go. Now I'm going to enter the word exit in all uppercase, and I want to see, let's check to see what happens. So we're going to next step this, or we're going to click enter, sorry. Here we are. So the response is capital exit. All right. What response.lower should do is it should convert it to a lowercase. And look, it did. Because it said, oh yeah, it does match this. This is going to break, and it's going to fall out, and we're good. Now, one more thing I want to do is I want to check to see if a number is going to hose this all up. So let's put a number in there and see if line 21 is going to fail. I'm not going to debug. I'm just going to put number 5, and it worked just fine. So this did not care. If it can't to lower it, then it falls through, which is fantastic. So I want to say right now, if you're liking these videos, please like and subscribe. They make my life a lot easier to understand what you're looking for and how I can better assist you in your development journey using Python. I have other videos out there as well for C#, C, JavaScript, Java, and the like. So please go check those out as well. And I'm always updating these videos almost quarterly, so keep an eye out for updates to these videos as they are released. Otherwise, as I say in all of my videos, good luck, have fun, ciao.